In the upcoming video, I will show you how to build the best water storage. Yeah, and the video will have two parts. Like in one part, I will show you an idea that's not really known and how they did it and why it's like the best method. And in the second part of the video, I will show you how to improve it even better. So first, with the first idea, the idea comes from German shipbuilding. Basically, in the World War, they started to make ships combining concrete. I know it sounds crazy. They started to build ships from concrete and it worked. It was amazing. And they managed it the following way. They put several layers of chicken wire in it. So that way they had like the strength. However, they stopped the cracking. And I know it sounds insane, but ferrocrete boats basically are lighter and they are more powerful and durable, or at least like comparable with the fiberglass boats. The only reason, I know your question here, the only reason they didn't start to make every boat out of that, it was mostly about the insurance, because the banks didn't know that how you actually make it. They weren't sure about the manual labor. And why they didn't use it? Because if you think about it, like the concrete itself, if you like the material or not, like it's organic or not organic, kind of cheap. So that wasn't the problem. The problem was like the manual labor part, because applying the concrete in like a thin sheet on the chicken wire, maybe a 1-inch maximum, it was like really hard. And if you live like in Africa or like India, where the manual labor part is cheap, they used it. So even today in Africa, they use ferrocrete water storages to store water. However, if you think about in Switzerland, they don't use it, because for them it's like easier to just buy something really expensive, because for them the manual labor is like the hardest part. And within this video, I will show you how to make it in an even cheaper way. So basically, we'll have the benefit of using concrete. And please don't argue with me like it's a organic material, it's not organic. We have to agree it's cheap and it works. And if you use way less than other persons, or you don't use metal, that's a problem as well. Because you have to compare them, you know. If you use like 10% or like 5%, sure, the material itself, it's not like the most energy efficient material. However, because you use like 5% of it, it's a good deal, you know. So bear with me for a second, even if you're like anti-concrete and you don't like it, just bear with me for a second. Yeah, sure, on the channel I will show you other materials that like are way better or not better, but they are comparable. But now we'll stick with the ferrocrete part. So okay, so we have the ferrocrete, that's like cheap, because you need just like chicken wire and you need a thin layer of concrete, like maybe an inch, like 2 centimeters, 2.5 centimeters, just like that, basically nothing. And you will need like the manual labor. How to make it without a big cost on the manual labor. And just keep in mind that one of the users watch it from Anchorage, Alaska, and the other one will watch it from Africa. So I can't get into the details how to do it and what's your terrain. Maybe one person will build it on sand, the other one on ice, the third one like in bedrock. And please, without doing anything, because you don't have to, like the law is not telling you that you should go to an engineer, but please go to an engineer and ask them how to do it in your area, on your land, basically on the earth that you are, because it's really important. If you think about it, maybe you can get a way to build it even cheaper than I tell you, because you talk with an engineer and said, oh yeah, but our earth is this and that, or they say, oh yeah, but you actually need a foundation here, and the other one will say, oh, with that size that you want, you don't need a foundation. So please, again, don't say it's working for me or it's not working for me or it's cheaper or not. Just get the main idea here and talk with an engineer. And if you're like really cheap with it, then go to the university and buy some ice creams for the kids, like in the 2nd and 3rd year, and ask them, and they will calculate you on the spot in like 3 minutes and you will get the calculations. But seriously, don't be cheap here. Just pay somebody to help you if you're like not an expert here. So okay, so were persons did it wrong. And afterwards they put the chicken wire between the pores and they start to apply the ferrocrete in it, like basically the concrete on the chicken wire. And that won't be like, it won't be as beautiful, it won't be round, and it won't be great looking, and it's like a lot of work, and probably like I'm absolutely sure about it, they won't be able to make it like 2.5 centimeter, like 1 inch thick. So basically you might put like maybe double of the material in it. I think there are like many methods to do it. So look, that's how others do it. So basically I'm drawing from the upper part, they put like a center and they draw like a circle. Oh yeah, sure, it looks great. And they start to put down like piles here. Okay, I'm not like drawing them more, but you get the idea. And afterwards, when they are ready, they start to apply the chicken wire here. They start to apply the chicken wire, and when it's ready, they start to apply the concrete in it. And it's not good, like as I mentioned, because of the manual labor involved. And the best idea, like one of the ideas, because basically you can make it in different ways and depends on the earth beneath it and depends on the height of the water. But I would go with the following. Let's say like the most cheapest version when you don't need a really big one, then you can even substitute ferrocrete. And it's a material that I really love. I think it's golden and nobody talks about it. It's this, I will show you a picture. Basically they use it at the foundations of the house. They put it between the earth and your concrete foundation. And the main idea or the main purpose of the material is to don't let the water stay or accumulate on your walls, because the house will soak up the water. And that material is like extremely powerful, and it repels water and it can resist on the sun like for years and years and years. So basically if you want a small water storage that can resist like 5-10 years, I would go with that without a problem. So basically you just put down the piles in a circular way and you put that material around it. And you start to put like a pond liner in it or like a nylon, it doesn't matter, and you start to fill up with water. However, if you want something bigger, basically like 10, 20, 30, 40, 50 square cubes of water, I wouldn't go with that. I would go with ferrocrete. So basically the black material, it's like really good because it's like really cheap. Here in Europe where I live, it costs like approximately like 25 meters long and 1 meter tall. It costs like $20, something like that. I don't know in feet, but an Olympic size pool is like 50 meters long and 25 meters width. So basically that thing has like half of the Olympic size pool length, and it has like the width of the Olympic size pool, and it's not that high but like half of it, something like that, and it costs like $20. With that you can make like a huge water storage, and you just need the nylon and a few piles if you want to do that. However, if you want something that will resist more than 10 years, because that thing will resist. So if you don't have like kids and like don't know, like dogs jumping in and out of it like every time, like 20 times a day, probably it will resist and it will work for years. Like I'm absolutely sure. You put a pond liner in it, or you put like a nylon that's used for greenhouses, and it will work amazingly. However, if you want something that's like fancy and you want to use it maybe to kayak in it, or you want to swim in it, and you really want to use it as yourself, then I would highly advise to use ferrocrete. With ferrocrete, everybody would start to pile down the piles. Afterwards, they will start to apply the chicken wire on it, and that's like a lot of hustle, a lot of work, and actually you can't apply it. So theoretically you can do like a 1 inch thick thing, like half an inch on one part, half an inch on another part, but in real life you can do it, because it's like really hard, and it will fall down, you will apply it, it will move, you will apply it. So basically you won't be able to do it like under like 2 inches, that's like 5 centimeters. So basically you like double your material needed, like just from start. And the other one is like a lot of manual labor, and you kind of have to do it at once. And here you have like several methods, and depends on how big the water storage should be and how tall it should be. So one of the best advices here is keep it low, like seriously. So basically, the taller the water gets, the more rotational forces you will get that will try to rotate your walls, basically put your walls down. And I would rather do like 2, 3, 4 smaller ones, or one that's even bigger than one that's tall. Because if you think about it, if you make it like 1 meter tall, 1 meter, I don't know in feet, but let's say a grown up, like a basketball player, is like 2 meters, it's like 7 feet, I think. I'm not sure, but it's something like that. So if we are talking about like 1 meter, in 1 meter water, it's like half of the tall person's height. You can swim in it, so if you want to swim it, you can swim in it. However, the rotational forces are almost nothing. It's like an Intex pool, you know, like that height. It's like really, really, really low pressure. So with that, you can get away with chicken wire, because with the other one, you can't. There you need like really, really, really expensive things. You need like a really good foundation, and you need like serious metal in it, and it will cost. And I don't want to show you like exactly how to do it, because everybody's like budget and everybody's skill set is different. However, you should consider to make it like modular. So basically you don't put the piles in the ground, and you don't put the chicken wire between the piles, and afterwards you try to apply the concrete in it. You can do that, it's working, but it's like labor intensive. If you want to pay somebody, and you can do that. I just say like sometimes it makes sense to make it in a modular way. So basically you check how much is the space between two of the piles, and you put the whole thing like a table, you know, like a table. You put it on the ground, like with a rotation shape in it, and you just put the concrete in it. You leave it like for a day or like 2 days, and afterwards you can put it in place. See? So basically that way you can make it perfect. It's not that you won't have to work that much, but the end result will be perfect, and it will be like really, really thin. And every day, let's say you make like 2 or 3 pieces of that, and afterwards, like in a few days, you're ready with it, and you put it in place, and it will really look perfect. Just don't ask me like, oh, do you screw it or you put metal? It depends on you. I'm just saying, consider the idea of making it from modular places, because that way you can basically put it on a truck and you just ship it anywhere, because it won't crack. It will be ready, and the chicken wire is already in it, you know, so it won't crack. So just consider the idea. And the other one, like, and I want to hammer the idea over and over and over again, don't go above like a meter or something, because the rotational forces are way bigger, and you will need way more metal in the thing, and it will cost basically way more, and you don't want that. And consider an idea. So basically, if that is like extremely big, it can crack, because if you don't have like a proper foundation, and that's what we don't want to do. We don't want to spend like a lot of money, and depends on the climate and depends on the earth. However, make it not from one piece, make it from different pieces. So let's say you have here modules, like that's the pile, and that's the ferrocrete part, like one module. Look, that's the second one, like the pile. See, and that's the second module. Let's make another one, like that's the yellow, coming like that. And now I'm drawing one, and I show you what's the main idea here. So basically, here, when the water pushes in the outside, look what happens. So here you have a pile. Wait a bit. So here you have the piles, so it will stop automatically. They can move. And here, because the module, here you see, the module is longer than the distance between the two piles, that will crush here. So basically, it will be something like that. It will become after on the another one. And if you put like a pond liner in it, it will hold the water. And if in time, like in 5 years, in 10 years, between the two of the modules, it will start to move like half a centimeter, half of an inch, even an inch and 2 inch, it wouldn't be a problem because it will move and nothing bad will happen. Way to know that, oh, I didn't make like the most expensive foundation, I didn't put like a 20 centimeter thick concrete, I didn't pay like a lot on engineering, I didn't pay a lot of like terraforming earth here. However, I have the same benefit and it kind of looks the same. And if you don't like the pond liner, then you can use like silicone or other some kind of materials that will close it. But the main idea is, think about that, making it modular and leave it to move, you know, just leave it to move, because why not? If you think about like the Intex pools are moving all the way, if you like jump on it, it like moves like 5 centimeters and the water remains in the inside. Like if they can do it, why we can do it, you know, like just think about it. And what I like here the most, basically the edges, the walls don't take that much of a concrete. So most of the concrete here, it wouldn't go in the edges, it would go on the foundation, like the lower part and the foundation in the normal way. So basically here, if you don't have, so look, if we don't put concrete on the floor and we use a pond liner or we use a nylon or anything else, and we don't put like 10, 15, 20 centimeters of concrete there, that means we are not spending money. See, we're just spending money on the edges, and the edges cost barely nothing because we need just like a 1 inch of concrete and some chicken wire, and in some cases we need more, but usually we don't. And we don't need the foundations, or at least we need like a really small foundation. So basically, if we consider it, we can get away with like a fraction of a fraction of the fraction of a price. And even so, if it's like a problem and you see it's like starts to crack, you can repair it like really easily. You just go there with like 1-2 layers of chicken wire and you put it on it and you apply more concrete, and that's it, you solve the situation. And covering it, I think it's like the most easiest part. Basically, you need some piles here and there, like metal between them, like of course. And between the metal and the roof, basically you apply chicken wire as well, like 1-2 layers of chicken wire, and you put like 1 inch of concrete on it, and it's like kind of ready. And you can do it in the afternoon. I'm not exaggerating here, it's like that simple. And you have a stage there. Like seriously, you can use it for like a terrace, like literally you can use it like a terrace because it's big, so the space is not like thrown out. Or if you want, you can put like earth on it, and if you put earth on it, you can like plant grass, put bushes, or just let the wildlife come back. So I highly encourage you to like think about the idea. And the rooftop is like the most easy part because you just have to, like I'm exaggerating here, you just have to throw concrete on it, and basically that's it. Consider the idea, it would cost pennies compared to any other method, and it's like really easy and really fast to do it. And that's it. Okay, see you.